Why are polar subglacial lakes geologically unique? Imagine lakes hidden beneath miles of ice, completely cut off from the surface world for hundreds of thousands of years. That's what makes these subglacial lakes so fascinating. They are found beneath the thick ice sheets of Antarctica and Greenland, and they are unlike any other lakes on Earth. Because they are sealed under kilometers of ice, they stay isolated from surface weather, sunlight, and even the atmosphere. This creates a very stable environment that can last for thousands of years. The water in these lakes is kept in a liquid state mainly because of heat from the Earth's interior and friction from the moving ice above. As the ice slides over bedrock or sediment, it generates heat that melts the ice at the bottom, forming these lakes. Some of these lakes, like Lake Vostok in Antarctica, sit beneath about 4,000 meters of ice and can be over 1,000 meters deep. The pressure from the overlying ice actually lowers the melting point of water, helping keep these lakes in a liquid state despite the freezing temperatures. The physical properties of the water are quite different from typical lakes. Because of the pressure and temperature, the water can have temperature gradients that cause convection currents. Warmer water rises while colder water sinks. Salinity levels can also vary, creating layers of fresh and salty water that don't mix easily. The sediments at the bottom of these lakes are just as interesting. They often show fine layers or laminations, which tell us about how long the lakes have been stable and how they fill and drain over time. These sediments are like a history book, revealing clues about past ice sheet movements and how water flows beneath the ice. Microorganisms can survive in these lakes too. Since they are cut off from sunlight and nutrients, only extremophile microbes, organisms that thrive in harsh conditions, can live there. Finding microbes in lakes like Lake Vostok has opened new doors for understanding how life can exist in extreme environments. These lakes also influence the behavior of the ice sheets themselves. They act as lubricants at the base of the ice, helping the ice slide over bedrock, and their cycles of filling and draining can affect how the ice sheet moves and melts. So, these lakes are not just isolated bodies of water. They are active parts of the polar environment that shape the stability of the ice sheets. In short, polar subglacial lakes are unique because they are sealed, long-lasting, physically and chemically complex, and biologically intriguing. They are windows into Earth's past climate, and they might even hold clues about life beyond our planet.